Thank you very much for the introduction. And so I'm going to be talking about voice computing with Python in Jupyter Notebooks. And I'm not a professional programmer. I'm a university professor in biochemistry. I work at the University of Oklahoma Health Sciences Center, or that's what it used to be called. They dropped the center from the name just several weeks ago. It's a hard habit to break. So my lab works on determining the structures of proteins. Oops. That are important in cancer. And so we use a method of protein crystallography. And so we grow crystals that are fractions of a millimeter in length that contain the protein of interest. In this case, we have on the bottom row a RET kinase with a drug bound. Then after growing the crystal, we mount it in we place it such that it can be struck with X-rays by this instrument in the middle, X-ray diffractometer. It gives diffraction spots. We collect those spots, and as we rotate the crystal, so we can get all the possible diffraction spots, we then process that data with computers, and we do an inverse Fourier transform to get an electron density map represented by the chicken wire, the blue chicken wire that you see in the middle. And then we compare structures of complexes with different kinds of drugs and with mutants that resist binding some of these drugs so that we can learn how to design new and better drugs. The mutants emerge after treatment with the first generation of drugs. After several years, there's a need for additional drugs to keep people alive. Oops. So I have been developing tools in Python to make it easier to use some of the software that we use in our workflow. And so these are some examples of some publications on this matter. So the problem that I encountered last August was my repetitive stress injury flared up. And this is as a consequence of working on too many writing projects. This is what AI thinks a structural biology professor looks like who is working on many parallel writing projects. He has the advantage of having 10 fingers per hand. So beyond this problem with RSI, you might actually have lost use of your hands due to accident or disease, or you may have lost use of your eyes. And so voice computing is a necessity to work with computers. Or you may be aware that as knowledge workers, we tend to get really engaged with our work and want to sit in front of the computer for more than half an hour when we really need to get up every half hour, move around. And you can continue to work by using voice computing. I can dictate to my computer from 20 feet away while looking out my office window or home window. And then it might be that you are a very fast typist, and so voice computing may not sound very attractive to you because you can type faster than you can talk, but you can't really sustain that for very long, and you might want to extend your period of productivity by using voice computing. So I divide voice computing into 3 activities. These are just what I came up with. So speech to text you've heard of before, that's just dictation. And there's the conversion of your words into commands that run your computer. I call that speech to commands. And then there's speech to code, which is essentially very similar to speech to text. You're using your voice to write code. So as I mentioned, in mid-August, I ran into a wall. I was working on filling in the cells of a database through using a GUI, where I was overusing the mouse to copy and paste. and I thought I had to do something different. So I picked up on voice computing. I show here the number of words of prose that I generated in the prior 2 months. And then I show the number of words that I've been generating in the subsequent 2-month periods from September and October onward. And these different 2-month periods are very similar in terms of the number of days I was out of town, where out-of-town travel was disrupting my regular writing schedule. Now, I know for this audience, perhaps a more relevant metric would be a number of lines of code written, but my main job is writing prose, and so I think this is a pretty good measure. You can see that there's been a 3-fold increase in my output at a minimum. So the problem, though, with dictation and all forms of voice computing it's not perfect. There have been major improvements over the past decade as a result of the incorporation of neural networks into language models, but there's still issues these errors can be divided into 3 categories. The first one we can do something about. This is the getting the wrong word returned. The second category are some words that are omitted. And then the third category is the addition of words, the hallucination problem. So I tried several different speech-to-text software packages, and the one that's worked well for me is this VoiceIn plugin available for Google Chrome and for Microsoft Edge. Unfortunately, you have to pay $39 a year to get the ability to add in speech replacements to correct mistakes that the program makes repeatedly. But having that ability is what I'm going to capitalize on in this talk. So this shows the GUI interface that you gain access to when you pay your $39 subscription. And this shows the top of a table with all the customized commands that I've entered. I have 18,000 now. And the first kind of irritating command for somebody who has to write nonfiction is our English contractions. So contractions are wonderful for informal writing, and I guess by default, the developers of this software assume that you want to use contractions. If I say cannot, I get can't, and I can't submit papers with can't. I have to use cannot. So I have identified 186 contractions, in some very common, some not so common in English, and I have put them together in a CSV file and posted that on GitHub. So another problem is names, like my own name is returned as if I were from North Africa, and I'm not of North African descent. So I can replace what VoiceIn returns for my name with my proper name. And so this is great with your friends and colleagues, especially ones that have difficult to remember last names in terms of the spelling. Then a second category involves the insertion of code, and I actually make up my own sort of command language. So I use the term insert before various items to indicate I want code inserted. In this case, it's a item in a list in LaTeX. So I do a lot of my writing in LaTeX. And so I have insert item mapped to new line as in angle brackets. So this is part of the command language that's built into VoiceIn. And then I have space, and because I want one white space before item, and then another space, and then capitalize. So the first letter, the first word in my itemized list is capitalized. Then you can insert multi-line pieces of text replacement, as shown on the left. So I have an itemized list template for writing in LaTeX. And then on the right, I have an example of another kind of verb, expand. So if I want to expand an acronym like MCMC, so I can never remember whether it's Markov chain, Monte Carlo, or Monte Carlo Markov chain. So this takes care of those kind of mistakes. So beyond the expand for acronyms, I also have the book, and then whatever the book title is, and then I have returned that book title in quotes with the name of the author, which I tend to forget. And then another one is email. So this software will operate in any text area, almost any text area in a web browser. So that means for webmail programs like Gmail or Outlook webmail, this works. So I have a mailing list of 180 addresses for a data science workshop that I host on a monthly basis. So if I just say email DSW, that mailing list is inserted. So it saves a lot of trouble. I've already talked about insert, list. So list of things like all the different font sizes available to you in the Beamer package in LaTeX. I can never remember those. Then there's another command, open, that you can use to open up specific web pages, like the meeting web page for PyTexas, for example. And then I have another, I use display to insert a specific equation in the display mode in LaTeX documents, but also in Markdown cells in Jupyter Notebooks. And then likewise, inline for inline equations. So how do I use Jupyter Notebooks in my lab? We use them to prepare images for publication. So we often have to make many draft copies of molecular graphic images of our molecules in all kinds of orientations, with all kinds of different representations. The Jupyter Notebook is a wonderful format for storing those images, and then you can easily share them with others, and you can scroll through the notebook very quickly and compare images, decide on which one you want to submit for publication. So I'm going to actually, so voice computing is extremely dangerous to do live, because you never know what's going to be returned. And yeah, I shouldn't repeat what my experience, but
header 1, delete word, demo of the use of voice snippets in Markdown cells in Jupyter. Delete word, cells in Jupyter. New line. This is the electron density equation, colon, new line, display electron density equation. Now I'll render this cell. So there we go.
So this is an equation that we use to take those diffraction spots you saw in that image and convert them into electron density in terms of number of electrons per cubic angstrom in real space. So this is
Run voice in quiz. Control enter.
So this is an interactive quiz that I put together. So this is was inspired by Al Sweigert's book, Automate the Boring Stuff. He's going to be speaking tomorrow morning at 10:15. And this can be run in the terminal, but it seems to be a little more fun to run it in a Jupyter Notebook because you retain a record of your answers.
So now we enter 1. And then in this blue box, we would enter the answers. Unfortunately, your voice will not work in this blue box. It's not recognized by VoiceIn. So to scroll up in the Chrome browser, we would enter scroll up. So this isn't the same as going to the top, which would be scroll top. So if I had entered the wrong answer, like to close tab in the browser, if I entered instead open tab, I may get the wrong answer, and it will report back to me the correct answer.
So this quiz is, the questions are randomized every time you take it. It's a new quiz, essentially. And as you go through it, after you accumulate 5 wrong answers, you will then have those questions fed back to you, so you have an opportunity to answer them again during your given quiz session. So if you do this like probably 3 times, you'll be ready to go on a given day with this software. And if you do it over every other day using spaced repetition, you'll wind up remembering the command. So not very many of them, actually. There's, I think, 50 questions in this quiz. Oops. Okay, so the other kind of cell in a Jupyter Notebook is a code cell. So I need to do a code demo.
Insert MTZ summary.
So I had said the word and that got captured in this cell before I said the name of this voice snippet. I call these voice triggers, kind of like tab triggers, and if you're familiar with snippet libraries and text editors. And so the only thing that had to be customized was the name of this MTZ file. The MTZ file is a binary file format that was developed in the probably in the 1990s for the purpose of storing crystallographic data in a compact format. At the time, the data files were large. Now they're puny compared to the sizes of files that people work with today.
So we now have a summary printed in the Jupyter Notebook of this MTZ file, the plot of these I plus versus I minus values, these intensities that have the same index but different opposite sign are supposed to be equal in value unless there are anomalous scattering atoms present. Insert anomalous pair plot. Okay, so we have victory at last.
So what's going on in that plot is we're plotting the plus values against the minus values. And the plus and minus values are just the indices of these reflections that are related by symmetry. They're supposed to be identical if they're following Friedel's law. But if there's anomalously scattering atoms present, in this case, some sulfur atoms, that can cause a difference in these intensities. That's a real difference. And as we saw, as intensities grow larger, the differences grew larger as there are greater deviations away from from a line with a slope of 1. And there was actually a real anomalous signal in this data set, and the people who collected these data were able to solve the structure using that anomalous signal. So what are the hazards of voice computing? So I've had people walk through my office door, and whatever they were saying got recorded in the document that I had active. Then you can introduce bugs into your code by saying words, or other people saying words that get captured. And then you can run into trouble with external microphones blocking the internal microphone. And then I have used other speech recognition software, and in parallel, I've had them interfere with each other. It leads to rather humorous results. So I didn't talk about a lot of other software. You've probably heard of Dragon Naturally Speaking, which has been available for well over a decade. And you're able to customize it with so it's such that it recognizes your voice and your accent and so forth. Then there's Town Voice, which is a wonderful package. It's open source, free, but I found it to be very frustrating to use in terms of speech to text. It has a very high error rate compared to this Voice-in Plus I've been using. However, you can do far more with it than you can do with Voice-in Plus in terms of customizing. It's really a tinker's dream. If you're an Emacs user, this will really appeal to you, because you'll spend half your day just coming up with new town voice commands. Then Serenade is another program focused on using your voice to write code. It looks relatively straightforward to use, and I plan on pursuing it in the future. Then there's OpenAI's Whisper. So I use that to transcribe my audio. So I've been using a digital recording device, and so I record notes during my commute, and I use Whisper to translate those or transcribe those into text, and it does a pretty good job. And then there's Mac has a dictation software which has been improved dramatically over the past year. It's great, but if you have an ancient Mac like I do, an Intel that's based on an Intel chip, a remote server is used to convert your sound waves into text. So there's a latency issue. It'll quit on you after 2 or 3 sentences, and whereas Voice-in doesn't have that latency problem. You can go for multiple paragraphs before you might get ahead of it. And then there's a voice control that's available in the Mac that allows for the writing of customized commands. And then there's Deep Scribe for people in the medical field. And of course, we know about Siri and Alexa. So as you've seen, I've had a big speech computing has become a part of my workflow because of its big impact in my productivity. And then you've seen how I've taken advantage of text replacement feature in Voice-in Plus to generate voice snippets. And I'd like to acknowledge my students who have, for whom I've developed some of the Python software in the past, and then my colleagues and friends in Oklahoma. We have a monthly Oklahoma Data Science Workshop where somebody will present about something that they're doing with scientific computing. And this is open to anybody, just my institution's providing some support for it, so we have to call it Oklahoma. But if you're interested, send me an email, and we can add your name to the email list. And I am an Emacs user too, and so I participate in one meetup that's based here in Austin, actually. online. And then the NIH supports my research. I'll be happy to take any questions.
Excellent. Thank you so much. That was incredible. And we do have questions for you. So let's start off with this. Someone asked, said, I converted my API from camel case to snake case for better accessibility for a vision impaired user. Are there similar issues for voice input of code?
So with, well, I have run into difficulty with, in terms of the case of words. So you can control that with this voice in plus software. So you can have everything in lowercase, uppercase, sentence case, or go with a default. And sometimes that setting gets reset on you by accident, like to lowercase, and that can screw up code that has some uppercase letters in it. So that's a source of frustration.
Okay. Someone asked, have you looked at external applications like Voice Attack to have voice commands, macros, and shortcuts available outside of the web browser context?
Outside the web browser context, so Talon Voice will work, and Serenade will work outside the web browser. They'll work you can issue commands in the terminal, you can issue commands in GUI-based applications, and so forth. So I have looked at such external software.
Okay. Someone asked a question that I was wondering watching the video. How did you get it to go back and spell cells instead of cells?
That was by random chance.
Okay. Somehow that makes me feel better. I don't know that it should. Have you seen the talk Travis Rudd did at PyCon 2013? Have you considered using shorter or made-up words to accomplish commands more quickly?
Made up or shorter words? That's a good question. So I've been. So what I've found is you need to test the commands, and usually that takes a few minutes because you need to test several variants of the commands. And I sometimes will map multiple variants of multiple voice triggers to the same chunk of code to ensure that I get that chunk of code every time. And this can be, generally it's not too big of a problem, but occasionally there are some words that are, for which it's difficult to get back the text replacement you intended. And so I've had some cases where I've had to generate a dozen different voice triggers to get back the same text replacement.
Wow. Okay. Awesome. Thank you so much.
You're welcome. Thank you.